the recording now. And yeah, excellent. Welcome again. So in this part of the hour, we will be focusing on the worksheets for week 8, tutorial questions for week 8. Let's start sharing the screen. So what we've got, this is the motor pathway. If you scroll down, this is the online tutorial, motor pathway, and I'll be putting the recording for this tutorial here after the class. So let's go through the questions here for motor pathway. Cristiano Ronaldo is kicking the soccer ball in a backflip style. This is one of the famous throw for him. To kick the soccer ball, Ronaldo's brain has to first plan and program the movement before executing the motor program. Which parts of Ronaldo's brain are involved in each part of this process? Use anatomical terminologies and landmarks to describe the location of each of these brain regions. So the information related to motor pathway should be available to you here in the same section, week 8 section, under the somatic motor pathways, the lecture, the recorded lecture, as well as there are two main contents for the online videos, one related to the physiological role of physioanatomical roles of the cerebellum and basal nuclei, and the other one is for the pathological changes or disorders happening, what's the consequences there. So to start with, it asks us about which one of the brain region responsible for these three movements: planning of movements, programming, and execution. So which one of the brain region you think is responsible for planning of the movement? Remember the different brain regions, which include the primary motor area, the association area, the other related area in the brain. So which one you think will be the one responsible for planning and execution of the movement?
Planning is associated cortex.
Associated cortex.
Sometimes secondary motor area could be programming, cerebellum and basal nuclei, and execution, primary motor cortex, brainstem, and spinal cord.
Beautiful. Thank you, Masha. So here for associated cortex, this I'll put it in red color so you can easily see them. And the other one is for programming, is basal nuclei and cerebellum. And for execution of the motor output is primary motor cortex, which should take the message down towards the primary motor cortex, towards the brainstem and spinal cord. So the information for this one should be available to you in the motor lecture. If you go back into the slide 11, so this is planning, programming, and for execution of the motor, which is brainstem, primary motor cortex, brainstem, and spinal cord. Sweet. Now what we have is to look into the suitable motor pathway. So Ronaldo's brain executes the motor program and sends messages to his lower limb. Okay, so message needs to go into his lower limb muscles to contract, okay, the voluntary muscles. On the diagram below, draw the pathway involved in this movement. Label the following structure. So if you look into the scenario, it hasn't specified whether right or left lower limb, okay? It's just asking about information from the motor cortex into the lower limb. So we don't need to be specific, start from the right side or from the left side. You can decide which side you want to start, but for the pathway, it needs to be correct. So if you start from the right cerebral hemisphere, the information will need to go into the left lower limb. If you start from the left cerebral hemisphere, the information will need to end into the right lower limb. Okay, What we need to label this information: primary motor cortex, internal capsule, and we need to state which part of the internal capsule, cross cerebri, basal pointes, pyramids, white matter tracts in spinal cord, and state its location and the neurons. So what we need is to draw all of these here in this diagram. You can see that this is the same diagram we use for the sensory pathway, but for sensory, we start from the peripheries going all the way up. Motor start from the cerebral hemisphere and going all the way down. I'll see if I can enlarge or zoom in here. Might be easier for us to go down. No, we need to zoom out eventually. I need to slightly smaller that one. Yeah, I think now we should be fine. Yes. So I'll start the annotate. Use the annotate. All right. What's the name of the pathway that we need to use for this scenario, for information to start from the brain all the way to move to the voluntary or skeletal muscles in the lower limb?
Corticospinal pathway.
Corticospinal pathway. So you remember from the lecture, we said the 85% of the fibers decassate towards the lateral side. That's why we can say lateral corticospinal pathway. Okay, because this is the main pathway for the corticospinal. The other one is the anterior corticospinal pathway, just include 15%. So this is the one.
Sorry, Haydar, I have a question here. Even it's for a lower limb, still is a lateral, but not the anterior corticospinal pathway?
Yes, so upper limb or lower limb, majority of the fibers will decassate at specific level and descends through or passes through the lateral column of the spinal cord. Hence, we, for hand purpose, will use the lateral corticospinal, because only 15% of the fibers won't decassate till it reach into that particular section in the spinal cord, which passes through the anterior column of spinal cord. So it's non-significant as compared to the main one. For hand purpose, we don't need to memorize both pathways. If you memorize the main one, that should be sufficient. Okay?
Thank you.
Good question. So what we need is, let's label the sites. For me, because if the things has not been labeled, for me, I'll just start labeling. I'll just choose the side from my end. So here will be the right side. And I'll put the left side here. Left side here. And in this picture, Ronaldo is using his left lower limb. So the information, if to moving the left lower limb, the information need to start from the right. Again, it hasn't been specified which lower limb, so you can reverse it. But if the question in the scenario specifically tells you which part of the body or which specific skeletal muscles, you need to stick with the sides. Okay. So if this is the left lower limb muscles should be somewhere here. So I can put that one. So I'll just put left lower limb, or just put lower limb muscles. Skeletal muscles. Okay. So I'll put that one there. All right, so here we've got the lower limb skeletal muscles, or you can just draw a muscle, a simple diagram of the muscle, that should be fine. What else we need to label? The primary motor cortex, where I should be putting the primary motor cortex. Okay, beautiful, excellent. So this should be the primary motor cortex. So this area. This should be the region of the primary motor cortex. And what should we have here? What is this part representing?
Internal capsule.
Internal capsule, beautiful. So I'll put internal capsule. So this one should be somewhere here. This is the internal capsule, which is also part of the passing of the corona radiator, should be somewhere here. Corona radiator should be somewhere here. Just label the main components, so it's easy for me to go through that. Here is the section of the brainstem. The top one should represent what?
Cross cerebri.
Cross
Cerebropeduncle.
cerebri of midbrain. So cross cerebri is the exact portion for the passage of the fibers of the corticospinal within the midbrain. And the second component should be what?
Pons. Ponsis.
Pontis of pons. Beautiful. And what I should be putting here beneath it?
Pyramids of medulla.
Beautiful. Pyramids of medulla. So I've labeled these. And then we need to determine which white matter in spinal cord permit passage of the corticospinal pathway. It's called lateral corticospinal pathway. Beautiful. So it should pass through here, through this region. I'll put it in this region. So lateral column. So column. This will need to be on that side. Lateral column in this area. Okay, and then we've got the neurons. Okay, so let's start with the drawing. I'll this one. I'll start annotate. Okay, so for corticospinal pathway, which is a motor pathway, how many neurons it has?
Two neurons.
Two. These are what? Sorry, I'm just going through the comments. So we've got two. These are called what?
Upper motor and lower motor.
Beautiful. Upper motor neuron and lower motor neuron. So for sensory, if it is a sensory pathway, there should be three, first, second, and third. But for motor pathway, we've got only two, upper and lower. All right. So if we start, and for drawing, when we draw the pathway, if it is a motor, we should always start from the brain going downward. But if it is a sensory, we should be starting from the peripheries going upwards towards the brain. Okay, these are some of the basic components. Just going into the content, that is his right foot. Right foot. Yeah, sorry. Yes, Zachary, that's his right foot. But yeah, which makes sense. But I wanted to start from here, so from the right side. So it's eventually going to going into the lower, to the left lower muscles. Okay, if we wanted to go back, thank you. This is the right foot, not the left foot. Yeah, so it's the opposite. Anyhow, as long as it hasn't been decided on the sides in the scenario, you can start from any side, but make sure that it ends into the contralateral side, unless it is specified in the scenario. Okay, so to start with, here, if I want the innervation to go that inferiorly towards the left lower limb or left foot, so the information should be starting from the right cerebral hemisphere. Marshall have specified the area here on the medial side of the primary motor cortex. So the beginning of the upper motor neuron, okay, needs to have a rounded cell body, because this is the nerve cell body. And this is the medial side, which represents the face region. Sorry, this is not the actual one, because this is the face region. We need to start actually, not from this one, because it's, sorry, yeah, the fasting is really affecting me, because here it's the lower limb region. Another 5 more days. So from the lower limb region, which is on the medial components of the primary motor cortex. So this is the nerve cell body. starting from here. Then the information will need to go all the way through the corona radiata and then through the internal capsule. From there, it needs to pass all the way in through the cross cerebri of the midbrain, basal pointes of the pyramids, basal pointes of the pons and pyramids of the medulla. And what happens next?
Deposit.
Decassette, beautiful. So once it reaches into the pyramids, the fibers, we're still in with the upper motor neuron, it will decassate towards the contralateral side and continue all the way downward, passing through the lateral column of the spinal cord till it reach to that specific section of the spinal cord where fibers needs to supply that particular skeletal muscles. Then the upper motor neuron will enter into this region of the spinal cord. Any idea what we call this region of the spinal cord?
Ventral horn.
Ventral horn, beautiful. So this is ventral horn, which represents the motor components of the gray matter of the spinal cord. What happens here?
Synapse with the lower motor neuron.
Beautiful. This should be synapsed with the lower motor neuron. So this is the lizard tongue represents the end of this neuron, and then there will be the second neuron, which is the lower motor neuron, which will start from here, exiting through the ventral root of the spinal cord and going all the way to supply that particular muscle. Okay, what we need to put, just label some sections here. So this will be the upper motor neuron, and this will be the lower motor neuron. What else? And this is the skeletal muscle. Ventral horn, we've labeled ventral horn, ventral root. This will be the ventral root. Okay, of the spinal nerve. This is the spinal nerve itself, and going all the way there. And what we have here, this will be the decassation. I need to put somewhere here. So decassation. Okay, so we've got the decassation here at the medulla. And what else? Internal capsule. Which part of the internal capsule that permit passage of the fibers for the lower limb?
Posterior limb.
Sorry?
Posterior limb.
Posterior limb. Beautiful. So I should be putting someone here. Posterior limb of internal capsule. Okay. The more information you put, labeling all this stuff, you will get the full mark or very close to the full mark, because here, this question, we usually assign about 6 marks plus minus. For each correct content information you provide, you'll get 0.5. So you'll be collecting 0.5 all the way. So look, make sure that you've got the fibers, the number of neurons correct, the starting of the neuron, the starting point. If it is lower limb, it should be the medial surface of that particular cerebral hemisphere. As you are moving up, it will be the pelvic trunk region, upper limb, superolateral, and then most lateral part will be the face and the tongue. Okay, so make sure the starting point is correct and the decassation point is correct. And as you pass through different components of a brainstem, highlight specifically that part of the brainstem. And the synapse between the upper and lower motor neuron needs to be correct in the specific horn of the spinal cord. Have I missed anything here? Anything else you would like to add?
So Heather, I'm just wondering, because I have a note that for direct synapse on lower motor neuron for hand musculatures, otherwise we need an interneurons. So I'm wondering why we don't have interneurons at each cellular limb.
Interneuron you are asking? Okay, so the interneuron is actually, this is a very simple diagram of the corticospinal pathway. In reality, when you look into the reality, you may find a lot of interneurons that communicate, but for simplicity, we need to identify the main components of the corticospinal, or even for the somatosensory pathways. The interneurons usually play direct role to modulate. So the main purpose of interneuron, as we studied at the beginning of the motor pathway, is that they modulate the output. They either increase, if they are excitatory interneuron, they increase the output, or inhibitory interneuron, they inhibit. And you will see that they work more with the basal nuclei function. In addition to the reflexes, the reflex like muscle stretch reflex. But for the pathways, for simplicity, we usually include the main components of, or main structures of the pathway that play the role, the main role in that pathway. You can still include the interneuron, but it's not very significant. It hasn't played a significant role here as compared to the role of the interneuron for muscle stretch reflex, or for reflex arc in general. Good question.
Thank you, Ida.
Any other thing? Okay, so if you'd like to take a snapshot of this image before I clear the drawing in 3, 2, 1. Let's see what we've got. What else? I think this is pretty much summarize all the tutorial questions for the motor pathway. When you go into the, if I go back here into the main components, so if I go back here, you can see that prior or at the, for each week, I just put some hints for the what structures you'll be doing or what's the classes. So for Friday, it's not Good Friday, it's on Friday, we're for the motor pathways that we'll be doing on Friday, this is Friday, the pages will be 64 to 69. In that contents, there will be questions related to the other type of motor pathway, which is the corticobulbar pathway. So once you practice this pretty well, I would like from you to go back and practice doing or drawing the corticobulbar pathway. Pay attention into the innervation for which part of the body, through which lower motor neurons, and the innervation, whether it's contralateral, bilateral, or ipsilateral, because this will make nice comparison between the corticospinal tract and the corticobulbar tract. Okay, that's all from my end. So is there any last question before we close the recording? Excellent. Thanks, everyone, and I will see you this Friday. Bye-bye.
Thank you.